Hi everyone, I'm Christian and today I'm going to show you how to solve a classification problem using different machine learning models. We are going to use the iris flower dataset from scikit-learning. First, we are going to load the dataset and we are going to analyze it. We can see that we have four features and three targets. From 150 samples, which are classified 50 samples per class. This means that the dataset is balanced. Then we are going to split this dataset using stratified random sampling with a seed of 97. Stratified sampling ensures that all the splits keeps the same class proportion as the total dataset. First, the total dataset was split 10% for testing and 90% for validation and for training. And this 90% was then split into 11% for validation and 89% for training, creating a training set of 120 samples, a validation set of 15 samples, and a test set of 15 samples. Then I use the model decision trees. Um, and here the hyperparameter is the dip. Testing the dip from 1 to 10, we can see the result here that for a dip of 1, our model is underfitting because the split is two samples, it's just one split. But when we see that we increase the dip from 4 to 10, we can see 100% of accuracy. But here we can fall into overfitting because more splits, more nodes can risk and make more possible to overfit. So the best dip here is going to be 3 to generalize more the model, the data. And when we test it with the training test, we can see that for D3, we have a test accuracy of 100%. And for the most overfit dip, that is going to be 10, we can see a test accuracy of 93.33%. Then we are going to study three more models. The first one, the k nearest neighbors, that the hyperparameter here is the k value, that is the number of neighbors. And here we can see that for one single neighbor, we have a result of 100% accuracy. But this is a trap because the model is memorizing all the training points and classifying in one single nearest neighbor. And this is overfitting. As we increase the neighbors, we can see how the accuracy is decreasing, but this is not bad. This means that the model is generalizing. So here the best case will be 9, and we test it here. We have a test accuracy of 100%. Then we test the random forest model. Here, the hyperparameter are the trees. We tested from 5 trees to 200 trees. We can see the result here that for all the hyperparameters that we tested, we have the same result, 100%. So how we decide what a hyperparameter choose is because of the cost of computational cost. With lower trees, lower computational cost. So we here choose 5 or 10. We choose 10 just to be sure. And we test it and have a test accuracy of 100%. Then when we compare the models, we can see that all the models for the best hyperparameters obtain a test accuracy of 100%. But we can see that for decision trees, we can fall in underfitting or overfitting if we didn't choose the parameters right. And for K and N, also we can fall in overfitting for one single nearest neighbor. But for the random forest, we see that for neither not depend not de independent or regardless of the number of tree, we obtain the same result of 100%. So in this case, for this data set, the best one was the random forest. Thank you very much. Ya terminé, belleza.